Have you ever been at an airport just staring out the window at one of those massive jumbo jets and had the thought, how in the world does that thing get off the ground? It just seems to break the laws of physics. Well, today, we're going to pull back the curtain on this incredible piece of engineering.
First, let's just get a sense of scale here, because the numbers are staggering. A fully loaded Airbus A380 can weigh up to 560 tons. To put that in perspective, that's like piling about 400 cars on top of each other and then trying to make it fly. It's a truly mind-boggling amount of weight.
So that's the big question, isn't it? How does this gigantic metal beast just overcome gravity? You know, the force that's keeping you and me glued to our chairs right now. How does it just sail through the sky like it's nothing? Well, it's not magic. It's physics. To really get how a plane flies, you first need to understand this invisible war that's happening all around it. It's this constant four-way tug of war in the sky. Okay, so here are the four players. You have weight, that's gravity, always pulling the plane down. And you have drag, which is basically air resistance trying to hold it back. Those are the two forces working against flight. To win this battle, you need two other forces. Thrust, which comes from the engines and pushes the plane forward, and the hero of our story, lift. That's the upward force from the wings that fights directly against weight. Simple, right? To fly, lift has to be stronger than weight. So, where does all that lift come from? Now, if you've ever looked this up, or maybe you remember it from science class, you've almost certainly heard a very popular, very neat explanation for how this all works.
And that story is all about the special shape of a plane's wing. It's called an airfoil. The whole idea is that it's curved on the top and flatter on the bottom. This shape is usually sold as the secret sauce of flight. And the theory goes like this. As the plane moves forward, the air splits at the front of the wing. Now, because the top is curved, it's a longer path than the bottom. So the air going over the top has to travel faster to meet up with the air from the bottom at the back edge at the exact same time. And that faster-moving air creates lower pressure. This is all based on a very famous idea in physics called Bernoulli's principle. So the story goes, you get low pressure on top of the wing, higher pressure on the bottom, and that difference in pressure creates an upward force. Boom, lift. It sounds so clean, so elegant, and it makes perfect sense.
But what if I told you that this neat, tidy explanation we've all been told isn't really the whole story, and that some of the most important parts of it are just, well, wrong? Okay, so let's start poking some holes in this popular theory, because when you really look at it, a few major problems start to pop up.
And here's the biggest one. The entire theory hinges on this idea that the air molecules that split at the front have to meet up again at the back. There is simply no law of physics that says this has to happen. It's a completely made-up condition. In fact, wind tunnel tests show the air on top moves so much faster that it gets to the back of the wing way before the air from the bottom even arrives.
Then you've got this problem. If lift only comes from that special curved top, flat bottom shape, then how do aerobatic planes fly? Many of them have wings that are perfectly symmetrical. The top and bottom are shaped exactly the same. According to that popular theory, they shouldn't be able to generate any lift, and yet they fly just fine.
And here is the ultimate deal breaker. Planes can fly upside down. Just think about that for a second. When a plane is inverted, that magic curved surface is now on the bottom. So, based on the Bernoulli story, it should actually be creating negative lift, pushing the plane straight into the ground, but obviously it doesn't. So what's really going on?
The real answer, the one that holds up to all these tests, has a lot less to do with a gentle suck from above, and a whole lot more to do with a powerful push from below. And for this, we need to turn to a different giant of physics.
That's right, Isaac Newton. His third law of motion is one of the most fundamental rules of the universe, and it's the primary reason planes are able to fly. For every action, there is an equal and opposite reaction. So you see, the most important factor isn't actually the shape of the wing, it's its angle relative to the air it's flying through. This is called the angle of attack. This is the real secret. Even a totally flat plank of wood can create lift if you just tilt it the right way.
So here's how it really works. The wing is angled slightly upwards as it moves forward. This tilt forces a huge, massive amount of air downwards. You felt this yourself. Stick your hand out of a moving car window. If you hold it flat, not much happens. But if you tilt it up just a little, whoosh, the air shoves your hand upwards. That's Newton's third law right there in your hand. The action is the wing pushing air down. The equal and opposite reaction is the air pushing the wing up. That, right there, is lift.
Now this is where the story gets really, really interesting. You'd think that after more than 100 years of building and flying airplanes, we would have all of this stuff completely sorted out. But the truth is, it's a little more complicated.
The very first flight by the Wright brothers back in 1903 was only 12 seconds long. Now, more than a century later, physicists and aeronautical engineers are still debating the precise physics. Of course, they all agree on the outcome: planes fly. But the exact mix, the precise contribution of Newton versus Bernoulli, well, it's still a surprisingly hot topic of discussion.
So, does all of this mean that the Bernoulli story we learned in school is just complete garbage? Well, no, not entirely. But its role has been seriously exaggerated.
The reality is, it's a combination of both. Bernoulli's principle does play a part. There is a pressure difference, and it does add a little bit to the lift, but it's a supporting actor at best. The real star of the show, the primary driver, the main reason a 500-ton machine can get off the ground, is Newton's third law. It's the simple, brute force of the wings deflecting enormous quantities of air down, which creates that powerful, equal, and opposite pushback up.
So, let's just end with this thought. We have absolutely mastered flight. We build these incredible machines that can take us anywhere on the planet. And yet, the simplest, most common explanation for how it all works is basically a myth we're still trying to correct. It really makes you wonder, doesn't it? What other pieces of common knowledge that we all take for granted might not actually be the whole story?